Okay. All right, so everyone can see the presentation?
Yep.
All right, awesome. All right, so, well, welcome to the workshop today. So if you didn't hear already, it's going to be an introduction to REST APIs. Before I get into the presentation, I just want to remind everybody about the prerequisites. So if you haven't already downloaded and installed Node.js and Postman, if you can do that while we're going through the presentation, that'd be great. The links to do that should be in the announcements, and I believe they're also in the emails that we sent out. You don't need Postman, so if you haven't downloaded that yet, that's okay. You can use Postman on their website, but yeah. So before we get into the meat and potatoes, I just wanted to answer this question. So where do REST APIs come from? So believe it or not, if I remember correctly, some graduate student actually made the idea of a REST API. So I thought that was pretty cool, just because like you wouldn't really think that a grad student would, well, maybe you would, but you wouldn't really think that like a grad student would make like this really big, meaningful. Wow, this sounds like really bad now that I'm saying it, but well, I mean, it's cool to see that like a grad student like came up with this like design that's used like pretty much every day. So if any of you ever go to grad school, maybe you could also come up with some sort of groundbreaking design that is used every day. So before we go to REST API, I'm going to talk about what an API is first. So an API is, well, it stands for Application Programming Interface. And so usually like an API will kind of give you access to something or like some sort of resource. And a good API will also define how you can access that resource. And so if you've ever, I mean, we use APIs like all the time. So one API, for example, is like in web browsers, there's like a geolocation API. So if you've ever gone to a website and it's asked you to let it use your location, then that's the that's the web application invoking the geolocation API on the web browser, so that it can get your location. And another example of like an API. So like if you're developing like a smartphone app and your app uses like the camera of like the phone itself, then the language you're programming in, so say you're doing like an Android smartphone app, Android or like Google is like providing you an API so that you can access the camera of the phone. So that would be another example. And one time somebody told me that like if you're like the client and I guess like wherever electricity comes from is your database, then like the power socket in your wall is kind of like the API. And so a lot of times APIs will kind of like be the middleman between you and someone else or something else. So in a lot of cases, it's like a database. And so, for example, like SoundCloud has an API, Spotify has an API. I think like Twitter even has like some sort of API that you can use. But basically, these websites will have like an API that they predefine, and you can go on their like developer website or like make a developer account, and you'll get like some sort of special key. And if you have that key, then you can use their API. But I think like an example, well, at least for like the Spotify one, if you use their API, then you can like get some sort of information from their database. So like sometimes it's like information about like your user profile or like the songs you listen to or something like that. And so a REST API is a special type of API. It stands for Representational State Transfer API, and it uses a client-server architecture. But there's more to it. So REST APIs are just APIs that adhere to the rules of REST architecture. And so I'm not really going to get into the nitty-gritty of REST architecture, but we'll go over some of it. So how do REST APIs work? So typically, so like I said before, REST APIs are pretty much built on a client-server architecture. So a client could be your cell phone, and the server would be some like Twitter server or something, and an API is going to kind of be on that server. And like, say you make like a post on Twitter, then some information is going to be sent to like Twitter's like REST API, and then the server will be able to put your Twitter or your tweet in the database. So that's kind of like another example. I'm not sure if that's actually how Twitter handles when you make a tweet, but that would be like an example. And so REST APIs can be made, requests for REST APIs can be made in a lot of different formats, like XML, or just like raw text. A lot of the times it's going to be in JSON. And so that stands for JavaScript Object Notation. And so requests in REST APIs are made over the HTTP protocol. So HTTP stands for Hypertext Transfer Protocol. And so we use HTTP every day. If you're using a web browser, whenever you go to a certain website, you're using HTTP. You're making an HTTP request to some server that has the resources for that web page, and then that server is giving you a response with the resources. And so HTTP requests have something called a body, which we'll be using in the code along portion. So here are some examples of HTTP requests. So you don't really need to worry about this too much, but just so that you have like some sort of idea in your head of what we're using. So I hope you can all see my mouse, but so at the top left, we have the method of the HTTP request. And so in this case, it's post, but there are a lot of other different methods. For example, there's get, there's delete, and there's also patch, and we'll be using all of those today. And typically, when you make an HTTP request in your web browser, usually it's going to be a get request. And so next to the method, we can see there's a URL. So basically, that means this HTTP request is making a post request to this URL. And then beneath that, we can see that there are some request headers. So the request headers you don't really need to worry about today, but they just have like some extra information. What is important though, so about midway down in the request headers, you can see there's a key called content type. And so basically that will tell the server what type of content is in the in the body, and also not necessarily what the response is going to be, but this is kind of like representing what's in the body. And so at the bottom here, you can see there's a request body. And so if you look at content type, basically it's saying that the data is coming from some sort of form. So a lot of this is kind of gibberish in the request body, but basically these are kind of just like they're almost like kind of like keys and values. So there's one that says such type equals n. That just means that there's like some sort of key called such type, and then the value it's pointing to is n, whatever that means. And so here's another breakdown of like what a HTTP request looks like. So as I already kind of discussed before, there's going to be a method in the request. There's going to be a URL, and there's going to be some headers, and then at the bottom here, there's going to be a body. And here's also another example. So the method that it's using is get. Then the URL is some dir/page.html. The host means that it's basically just like the host server. So in the web browser, this would be www.someschool.edu/some dir/page.html. And so connection close, you don't need to worry about that. User agent just means that it's using a Mozilla web browser, and the accept language means that the client is expecting to get French back. If they were expecting like English, maybe it would be like en. But a lot of the stuff you don't need to worry about for today. But if you are kind of interested in learning more about HTTP or like some other networking stuff, I would recommend taking the networking class, which is ICSI 416. And so onto more about how they work. So like I said before, typically the HTTP request is going to go to some sort of URL. The API is also going to define URLs for different things. For example, so when you're looking at an API, it'll have like different URLs, and it'll tell you what they're all going to do. So the API might define something like this. Okay, so if you make a GET request to this URL, then it's going to say like, give you a response containing like all the cars in their database. So here, like www.somesite.com would be pretty much just like the home, or I guess like the main server. And then when you see /cars, it's kind of trying to narrow it down to some sort of resource on that server. So I have it as /cars. So it's trying to narrow down to some sort of cars, some resource about cars. If it was like /animals, it would be some sort of resource related to animals. And if I made a GET request to www.somesite.com/animals, then let's say like it would give me back all the animals that the site is storing on its database. So here are some more examples of a GET request. So I actually made a typo here. So basically what I am trying to do is actually I'll just fix it real quick. Basically we want to do that. There we go. So there we go. All right. So in this case, it's very similar to the first one. So we're making another GET request, and we're going to this resource cars. So what the API would define is this top one right here. So it's saying if you go to this resource, so if you make a GET request to www.somesite.com/cars/ID, then you're going to get the car in the database that has the ID of 1. And so what this is called a URL parameter. So when I put a colon in front of the root, or in front of like the stub on the root, that basically means that I can put anything there, and then when the server actually receives the actual route, then it's going to do something depending on what I give it. So since I'm putting 1 here, it's probably going to give me the first car in their database. If I put 10 there, it would probably give me the 10th car in their database. And if I put something like James, if I put /cars/James, either it would give me an error, or there'd be some other sort of route that was defined by the API. And if it sees that there's no car with an ID of James, then sometimes the APIs are smart enough to try the next possible route. So if I made a GET request to www.somesite.com/cars/1, or sorry, /James, and the database saw that there was like some sort of error because there's no car with the ID of James, then sometimes it'll be smart enough to try some other function that maybe James would work for. Maybe it would be like all the cars that James owns. And so right here we have another example. So this is making a GET request to www.somesite/cars, but we can see it's a little bit different from these other ones. So here we had a URL parameter. So that was a colon and then a variable name. So right here, so we have something new called a query parameter. And so basically what query parameters do are they kind of sort or filter your results. So a URL parameter is going to kind of define more of a resource. A query parameter is going to help with filtering and sorting. So in this example, we're making a GET request to www.somesite/cars, but maybe we're saying that in the response, I only want the cars that are blue. So I wouldn't get any cars that are red. I wouldn't get any cars that are green. In my response, I would only get cars that are blue. So the server, once it gets this URL request, it would look at the parameter right here. The parameter would be called color. And then, so you can also think of this as like key value pairs. So color is like a key, blue is the value. So the server would look at the URL. It would say, okay, I have a key and it's color and it's blue. And since a lot of times APIs are predefined and they'll have instructions on what to do, the server will know that it has to get all the cars from the database that are blue. So talking more about how they work. So in all these examples, I used a GET request, but you can use other HTTP requests as well, like post, patch, and delete. They all have different functions. And so there are some other concepts surrounding REST APIs that you might want to learn about, but that I'm not really going into. But another one is just that REST APIs are stateless. And so that might sound kind of weird, because I pretty much said that REST APIs are like giving you some sort of state. They're giving you the state from the database, but every call to your REST API is independent of any other ones in the future or in the past. So there's not really any state like saved on the REST API per se. It's in a database. So when I make a request to a REST API, the server is going to go to some database that's somewhere else, let's say. So there's not really any state to a REST API. And then another kind of idea to that concept is that each request should give all the info it needs to complete the request. So basically, if I say like, if I say get www.somesite.com/cars/id, actually, let's talk about this one. So maybe this isn't like the full URL. Maybe there's another one that's like this. Oops. All right. So maybe there's like some sort of URL kind of like this. So in this one, I'm trying to say that I'm making a GET request to www.somesite/cars, and I'm saying that I want all cars that are blue and that have snow tires right now. So in reality, you might not make some like a query like this, but basically what that is saying, what this bullet point is saying is that it's the client should say that you need like, well, it should make sure to include that you need this wheel. Whoops, that you need this wheel parameter. If you just put, if this was if this was the URL, and say that we completely forgot about my original example that was just color equals blue, then if I only included color equals blue and I didn't include wheel equals snow, then I'm going to get some sort of error from the REST API. So basically what this is saying is that well, all requests should give the information that it needs to completely request, or else I'm going to get an error. And so REST APIs are really useful. They kind of define like a clear way how you should access some sort of resource. And they kind of separate things away from like the actual state that might be stored in your database. So it's not really good for clients to have direct access to your database, just in case like something goes wrong or if there's like some sort of hacker. And it's also kind of just like good design patterns too. So REST APIs kind of help to separate things out a bit. It's separating your kind of like your logic from your state. So the logic would be in your API or in your server, and the actual state would be in your database. And they're also very flexible. And a lot of different clients can use REST APIs. So since all you need is a HTTP request and a URL, it really doesn't matter what language you use the REST API in. So if I have a REST API, I could use something written in Java to access the API. I could also use something in Python to access the API. So there are a lot of different ways to use the API and then get the information from your database. So you might also be wondering if like REST APIs are really all that. And so they're great, but they do have some downsides. So an issue that some people will have with a REST API is that they're not really good at updating your clients in real time. So basically, if I was trying to make some sort of application, say like I guess I could say Google Docs or something. For an application like that, all the clients need to be constantly updated based on what changes in the document. So, but the way REST APIs are designed is that only clients can make a request to the server. In REST APIs, the server will never make a the server will never like randomly send like some information to the client. So, if I was making like a Google Docs sort of application, then I would have to make it so that like I don't know, say every second the client would make a new request to the server to get the updated information. And so that puts a lot of strain on the client and the server. But there are and so to kind of like talk about that a bit more. So say like say my polling or say the client only made a request to the server like every minute, then there would be a lot of information that the client didn't have. So I can make the client can make a request 1 minute, say at like time A, and then get all the information from the server at that time. And then between that time and the next time, time B, there could be other clients that are making changes to the document on the server. And that first client wouldn't know about any of those changes. And if I'm making something like Google Docs where I want to be able to collaborate with people, then that's pretty pointless because I won't know what they're typing. And maybe they deleted something I was typing, or maybe we're typing the same thing at the same time. And that's some extra work that we have to do. So that's why you would want the client to like constantly make requests to the server like every second. But like I said, that puts a lot of strain on the API and the client. So there's other technologies. One example would be called Websockets. And if you're interested in those, you should look those up. But basically, WebSockets are similar to REST APIs, or at least they're used similarly. And they're another type of architecture that's used on a server. The benefit of a WebSocket is that the server can update its clients. So it's more useful for synchronization. So if there's ever any sort of change to the server, or like the database that the server is connected to, then the server can seamlessly and pretty much automatically disseminate that new information to all of the clients so that they're all up to date. REST APIs are not really good at doing the synchronization because only clients can make requests. So yeah, so that is that would be like one reason why you wouldn't want to use the REST API. And so the things we'll be using for the coding, so we're going to be using Node.js. So if you're not familiar with Node.js, it's a runtime environment for JavaScript. And so JavaScript will work in any web browser, and you can code in JavaScript in any web browser, as James was showing in the last workshop last week. But in order to run JavaScript not on a web browser, we have to use some sort of runtime environment, and Node.js is a popular one. I don't know if it's the only one, but it's the one we'll be using. And NPM stands for Node Package Manager. And so that's something very useful that comes with Node.js that we'll also be using. But basically, it makes it really easy to get things that we can use, like packages and libraries. So yeah. If anybody has any questions, feel free to ask. But other than that, we'll get into the coding portion of the workshop. All right, cool. So I'll take that as nobody has any questions. But if anybody finds that they do have any questions, feel free to interrupt or ask in the workshop text. I actually haven't looked there, but yeah. Anyway, so we're gonna be moving on. Alrighty, so I want everybody to, or anybody that wants to do the coding portion, you can open up a command line or terminal if you're on Mac. And so the first thing that we're gonna do is we're gonna go make a new directory. So if you're using Mac or Linux, you can say mkdir demo. And then also, I'm sorry because I don't know the Windows commands for these, but I know James would probably know, so hopefully he can help. But so we're gonna go into that new folder that we just made. So the first thing we want to do is we want to say npm init, and also if I'm going too fast at all, or if again if you have any questions or anything, just let me know. But so I'm also assuming that we've installed Node and npm by this point. Okay, so what we're gonna say is we're gonna say npm init, and so what this is doing is it's initializing a Node project for us, and you can pretty much just keep pressing enter. None of this is really important. The entry point up here basically just means that that's like the entry point for the server, so that's where it's gonna like start. It's kind of like where your main is in Java. And is this okay? Yes. Okay. So if we press ls, then we can see that we have a fancy package.json. And so if we open that, so I'm going to be using VS Code, by the way. But if we open that up, so we can see over here.
Nice color scheme.
Thank you. So this is our package.json. So if you noticed, it's defining a lot of the stuff right here. And this will be more important later on. But okay, so the next thing I want to do. So in the same folder with your package.json, what we're gonna do is we're gonna make a new folder, and we're gonna call it source, or just src. And then what we're gonna do is we're gonna cd into source, and also cd means change directory. In Windows, I'm pretty sure it's different. I see Robin said mkdir works for Windows.
CD is the same in Windows as well.
Oh, it is? Oh, my bad. All right. Oh, Carter is typing.
That's a good question, Carter. they I don't know, people name their projects a lot of funny things. I mean, look at the names of the Albany servers. All of the servers are named a bunch of weird different things. There's Head, there's Glacier. I think one of them is called Iceberg. Like they name the servers just weird things that sound catchy. The same way that they name these projects. I mean, it doesn't really have to do anything with nodes, I assume. It's an interesting question though, why they name, well, JavaScript being called JavaScript, there actually is a reason they called it JavaScript. They called it JavaScript because it was created when Java was at the height of its popularity, and they wanted to capitalize off of the popularity of Java despite them being completely different.
Yeah, that's a good question. I actually am not really sure myself. Okay, so our next step. So once we have our source folder, and once we're in the source folder, we're gonna say touch index.js, and then we're gonna want to open that up. Excuse me with my windows right here. I have to figure this out real quick. I have a secret cheat sheet that you're not supposed to see so that I know what I'm doing. I'm not doing this all by memory.
Could be worse. You could go in blind to the operating system workshop like I did and take 3 hours figuring out bugs.
All right. Okay, so now we have index.js. So this is where the fun starts. So the first thing we're going to do is we're going to say, we're actually going to go back to our terminal or command line. Or did someone just say something? Or am I thinking? No, I think so. Okay. All right. So what we're going to do here, what we're going to say is we're going to say Npm Install Express. And so what this is doing is it's doing some networking stuff, and it's getting Express from some faraway land. And so if we go back here, if you go back to your package.json, you'll see that there's a new section called dependencies. And so basically, dependencies is just like everything your app needs to work. But there's Express right now. So the next thing we're going to do, in here in your index.js, what we're going to say is we're going to say this. We're going to say const express equals require express. And so what this is doing, this is kind of like an import statement from Java. You can pretty much think of it as the same thing. And then what we're going to do is we are going to say const app equals express. And this is like making an Express app. And then what we want to do is we want to make a port, and we're gonna say it's 3000. And so also, if anybody's unfamiliar with JavaScript, so const means that the variable is constant, means that you can't change it. It's the same as final in Java. And so the next thing that we want to do is we want to say app.listen. So this is going to be a little tricky for anybody that's not familiar with JavaScript. So what we want to say is we want to say port, and then we want to say open and close parentheses equals greater than, and then open and close curly braces. So what this is saying is so port we're passing in. So listen is a function, some predefined function from Express, and so these are one parameter is port, or so basically we're passing in port as an argument. We're also
Everyone knows what a port is, right? Just off the just making sure. So ports are pretty simple. You can host multiple services on one address. So say you're connecting to your Minecraft server, hypixel.net, right? So you can go on the website hypixel.net on port 80. All internet traffic goes over port 80, and all Minecraft traffic, like game commands and stuff between the server and the client, goes over port 25565. So they're able to host multiple services on the same address via ports, essentially. And a bunch of different services have a lot of different ports. All web traffic is on port 80, and most other stuff like FTP, file transfer and everything, 22, 21, SSH I think is 21. I think FTP is 22. May have gotten that backwards. But there's a lot of different common ports for different applications, which you can look into after this workshop. I'll send a link to it. But yes, that's the first thing, because we want to host our application on a specific port of our choosing. Ideally, since it's a REST API, you do port 80, but you can also do any port that you want, especially if it's a test app. Normally, you'll host on either 3000 or 8080 or 8000 sometimes. I've seen a lot of different things.
Yeah, James gave a good explanation. And if you're also unfamiliar with ports, so you can kind of think of it this way. So say you're living on like some street, and there are a lot of different houses on the street. Then each house is going to be like a program. Each door to the house is a port, and each address for a house is like an IP address. Yeah, hopefully that helps. But yeah, so in here we're saying, so listen's a function, we're passing in a port. So that means the app is going to be listening on that port, and then there's going to be a callback function for the function, or for when listen returns properly. And so all we want to say is console.log. So console.log is the same as system.out.println in Java. We're going to say server. And also note that I'm using the backtick right here. So that would be a single quote. This is a double quote, and this one is a backtick. You don't need to use a backtick, but I like to use a backtick because it lets me use string interpolation, which is a fancy feature in JavaScript. So it lets me just say that. Otherwise, I'd have to say something like this. Now, note that I'm using this single quote right here. So if I don't use the backtick, I have to use a single quote or a double quote, and I also have to use concatenation. If I use the backticks, I can use something called string interpolation, and some people, I like it better. I think it is easier to read a little bit. Yeah.
And the example you just gave, the concatenation looks easier, but there's definitely cases where the string interpolation is way better than the concatenation. I've seen it many times.
Yeah. All right, so by this point, we actually have a server. So what we can say, so if you're in the same folder as index.js, you can say node index.js. So, and when I do that, it says server starting at 3000. And if I go to my web browser, if I go to that URL, so the reason I have to say localhost means that, so that means I'm going to the machine's IP address. Or I guess a better way to put it is I'm just going to this machine. So I'm going to the process that this machine is hosting at port 3000. And so when I go there, I get this error kind of. It says cannot get. And so that's because we haven't told the server what to do when you make a GET request. And so,
Tony, just a quick question. What was that last instruction you put on the terminal?
On the terminal, the last one I said was node index.js.
Okay, got it. Thanks.
Yep. Also, please feel free to interrupt me like Matthew just did. Don't worry about it. Just feel free to interrupt. I'd rather that you understand what you're doing. So, All right, so yeah, that's the server. It doesn't really do much though, so it's kind of boring. So what we're gonna do next is we're gonna say, we're gonna do something a little fancy. So right above where you say app.listen, we're gonna say app.get, and we're gonna put in just a slash, and then we're gonna put in a callback function. And so this one's gonna be a little different. So we're gonna say, oops. We're gonna open a parenthesis. We're gonna make a, we're gonna say request. So REQ is short for request. RES is short for response. So it's very common when you're doing some sort of JavaScript backend thing that it'll say request and response like that instead of actually typing out request and response. So just to get you familiar with that, I've done the abbreviated versions. But so this is another function. So it's another anonymous function. In JavaScript, we call these types of functions anonymous functions because they don't have a name. And so basically what I'm saying right here is that these are the parameters for that anonymous function. So when I'm saying app.get, Express, which is the package or library that we're using, is doing some stuff behind the scenes whenever I make a GET request to this URL, and then it's putting a request and response argument into the parameters right here. So you might not have followed on that. You might not get it, or it might be a little hard to understand the first time you're learning it, but hopefully it'll get a little easier every time you do this. So what I'm going to do next, so res is short for response. So what I'm going to say is I want to send something to the response. Or sorry, I want to send something to the user in the response. And so what we're going to say, we're just going to be really simple, really generic. We're going to say hello world. And so make sure you save your file here. And then what you're going to want to do is you're going to want to kill the process or kill the program going on right here. And then you're going to say node index.js again. So this is restarting the server. Every time you make a change to your index file, you're going to have to restart it on the command line. And so if we go back to our web browser, if we refresh the page, now you see hello world. So I made a GET request. So I made a GET request to my server, and then it responded with hello world. So yeah, so that's another example of the server. But yeah, so it still doesn't really do that much. So the next thing I want to do, we're actually going to do something. So back in your index file, what we're going to do is we're going to make an array.
1 second.
Yes.
Tony, how do you kill the process again? Because
So you're on Mac, right?
yeah.
So you can go here. If you press Control-C, it'll kill it.
Okay, got it. Thank you.
Yep, no problem. All right. So back to here. So what we're going to do is we're going to make an array in JavaScript. So JavaScript is not like Java. All I have to do is that so in JavaScript is very dynamically typed, so I don't even need to tell it what type of object is going to go into the array. So JavaScript is duck typed, just like Python. Okay, so we have an array, and basically what we're gonna do is we're gonna put some items into it. But first, what we're gonna do, we're gonna make a new get handler. So this time, instead of just doing a slash, we're gonna say /to-do, and we're also gonna do request and response. So this is just another function, just like before. Don't forget your semicolons. And so what we're gonna do here is we're gonna say res.send, and we're gonna do something fancy in here. So actually, what we're gonna do, we're gonna say const response equals json.stringify to-do items. So it's very typical for REST APIs to give the response in JSON format. And what json.stringify is doing is it'll take any JavaScript object and convert it into JSON. And so once we have done that, we're just going to say response.send response. Oops. All right. So now if we go back to our web browser, and actually, before we do that, make sure you start your server again. All right, so if we go back to our web browser, we'll refresh the page. So we still get hello world, and that's because we went to slash, just like that. So if we type in just localhost :3000/, which is what we define, what we defined right here, then we're just gonna get hello world. So if we type /to-do, which is what we just defined, we're gonna get an array. Our array is empty though, so it's a little sad. And we want to put stuff in our array because we're making to-do list items. So what you're gonna do for that, you're gonna say app.post. You're gonna say /to-do. Same as above, so request and response. Okay, so basically, when I say app.get, that means this is defining how the servers or the REST API is going to respond when it receives a GET request to this URL. Right here, we're defining how we want the server to respond when it receives a POST request at this URL. And so this is assuming that somebody's typing localhost 3000 in front, but you actually only need to-do. Sorry, /to-do. And so what we're gonna do here, so this is gonna get a little tricky. So we are going to say, whoops, we're gonna say, give me 1 second. We're gonna say console.log request.body. And I'm just doing that so you can see what it's looking like. And so this is where Postman is going to come in. So if you have downloaded Postman, I'll have you please open that up. And you should also be able to use Postman on their website. So I believe if you go to the link that's in the announcement reminder. It'll bring you to the download page, and it should give you an option to use Postman on the web. So that's another option, but it looks like you do have to make an account. So Postman is pretty good, so I would recommend just downloading it. Yeah, so I'm gonna assume that you've opened this up. So when you first open Postman, your screen might look something like this. If it looks different, let me know, or feel free to interrupt so I can help you. But what you're gonna want to do, under workspaces, you might have something called My Workspace. If you do, you can click on that. You might have something that says like Create New. If you have that, then you can click on that. But yeah, so if you click on Create New, it's going to bring you to a screen something like this. And I think if you click on My Workspace, it'll also bring you something similar to like this. But yeah, if you have any questions, please feel free to interrupt. So
it says that it wants, at least for me, it wants us to create either for workspaces, either create a free account or sign in. So that might take a little bit, unless anyone else has any other experience with that.
Oh yeah, you will need to make an account too. Yeah. So I'll wait. I'll wait like 3 or 5 minutes.
Okay.
Yeah. And also, if you don't mind, I'll have you type something in workshop text if you are following along, just so I can know who we're waiting for the to get Postman all set up.
Tony, David has a question in the workshop text channel.
Oh,
Can you answer that?
Yeah, sure. All right, so after you deploy your API, do you have to go back and edit all your methods to use the base URL? So by base URL, I'm assuming you mean something like
like the domain, the actual domain, like www.twitter.com or something.
Oh no, you don't need to. So once you have your API, you can leave it just like this. You don't have to say there's nothing holding you, or there's nothing in the server that we're writing that actually depends on that. So like after you deploy this, if you deploy this to like AWS, you don't have to like change like the base URL or anything. What matters is that your client has the proper base URL. So your client would need to make sure that it makes a request to whatever IP address or whatever domain name is at the server at AWS. So like right now we're just using localhost. If I made a domain that was like like tony.com, and all people would need to do is just type in like tony.com/to-do, and it would work for them. So the localhost 3000 isn't that important.
David, have you ever heard of URIs? The idea behind the REST API is the fact that you're only using the path portion of the URI from the address. So if you look at the image that I just posted, you'll notice that this basically this is basically every single link you ever see, including emails and whatnot, they also all fall under this format, per se. So in our case, we don't have any user info or anything, but most web addresses are hosts, and then the port is just set default to 80, and then the path. So you have your HTTP:// the host name, and then the path. And all that you need for express.js is the path that's being requested. The host name is just given, basically. And that's one of the good things, because it makes it so you can run it on anything without having to go back and put your own domain name in there, right?
Thank you, James. That was a better explanation. All right. So I'm gonna assume that you're all set up with Postman now. Matthew, are you all set or?
Oh yeah, I'm good. I've been good for a little bit.
All right, awesome. So all right. So what we're gonna do? So we're gonna go to create new. All right. So make sure your server is running. And make sure it's running on the newest version of our index.js. And so we're gonna go to Postman. And so in the Postman interface right here, you might have something like this. So if you do, you're gonna want to press this plus, and so right here you're gonna have a lot of different options for your requests. But for right now, we're just gonna do get, and so we're gonna type in the request URL. So this will be localhost 3000, and we're gonna say, so actually if we just do localhost.3000 or colon 3000, if you click send, you're gonna get your hello world. And if we type in /todo, you're gonna get that empty array. And so there's a lot we can do with Postman, which I'll be showing you later. So what we want to do now, we're gonna click this plus. We're gonna switch get to post. We're gonna type in localhost 3000/todo. And the part that gets tricky is that we have to go right here into our body. So this basically, Postman is helping us make an HTTP request. So that's why I was talking about HTTP requests in the presentation. And so right here, we have a lot of different things. So headers would be the headers of an HTTP request. If you remember, oh, it's not there. Well, anyway, so if we go to body, so we have a lot of different types. We have a lot of different formats, I should say. What we want to do is we're going to do raw. So click on under body, click on raw. And then on the right over here, it's going to say text. So change that to JSON. And what we're going to do is we're going to write some JSON. So what I did is I wrote open and close curly brace. And so in JSON, if you're not familiar with JSON, pretty much you can only use strings, numbers, objects, and arrays. So the open and close curly brace means that it's an array, or sorry, an object. My bad. And then we're gonna go by key value pairs. So this is kind of like a hash map, if you're familiar with that. But so what we're gonna say is we're gonna say to do. Whoops. Actually, well, first we're gonna say ID. And so ID is gonna be our key. Then we're gonna type a colon, and then we're gonna type 1, and we're gonna type a comma, and we're gonna make a new line, and then in another key we're gonna type to do, and the value for this one can be whatever you want, but I'm gonna make cookies. So when we click send, it's going to make a post request to the URL here, and in the body of the HTTP request is going to be this content, and it's going to be in JSON. There's actually one thing we need to do before we do this. So we're going to go back to our index.js. And so this is very important. What we're going to say is we're going to say app.use express index.json. If we don't use this, then it's not going to work. But basically, this is letting the pretty much, from what I understand, this is basically letting our server parse whatever response we get into JSON. So make sure you save your index.js and make sure you restart your server. And so we're gonna go back to our Postman, and if you make the send request, so it's gonna hang because we didn't tell our server what to do. But if we go to our terminal, if you typed what I have, if you have the console.log right here, then basically this is just printing out what we put in the body. So the way we get the body in Express is we say request.body. And as you can see, this is exactly the same as what we put in Postman. So what we can do is we can click cancel right here. But what we want to do is we want to actually add this to our array that we have. So to do that, we're going to say to do items dot push request dot body, and then what we're going to do is we're just going to send res.send json.stringify to do items. So what this is doing is it's putting whatever the request was into our array of to-do list items, and then it's sending the to-do list back to the client. So we're going to restart our server, and we're going to open up Postman. So if we do a get request, so I'm back in the other tab right here. So we're making a get request to localhost 3000. So we have an empty array. So if we do a post request, this is in the other tab. So if we make a post request with this body and we send it, we're going to get this response. So this is the array that we have on the server. And if you go right here where it says HTML, there will be a little drop down. You can click JSON and it'll look a little nicer. But so this is everything that we have in the array right now. And so yeah, that's pretty good. So the next thing we're going to do is we're going to say, what if you need to update to do item? Maybe you made a typo or something. So for this one, we're going to use a new type of request that we haven't used yet. So we're going to say app.patch. So this is going to be an HTTP request that uses the patch method. We're going to say to do, and so right here we're going to use the that URL parameter in action. So then we're going to make sure we give them our anonymous function. And so what we want to do when we make it an update is we have to get the ID from the URL. So the way you do that, we're gonna say a new variable. We're gonna call it ID, and the way we get that parameter is request.params.id. And so if ID was James, then I'd want to say James. You can make that whatever you want, and this just has to be the same as what's right there. But since we're going to use ID because that's going to be more readable than James. And so what we're going to do here is pretty simple. We're just going to we're going to just loop over all the items that we have in our array, and if the ID is a match, then we're going to update it with the body of the request. So we're going to make a for loop. This is very similar to Java. The most notable difference is that you have to say let I equals 0. In Java, you'd say int I equals 0. and we're going to say I is less than to do items dot length, and then I plus plus. So very similar to Java. And in here, we're going to have an if statement. So this is where we're going to check if the IDs are a match. So we're going to say this. So in so like I said before, JavaScript is very dynamically typed. So all I have to do, JavaScript is going to get the object at this spot, and it's going to get the ID field from it. And so in JavaScript, you have to use the triple equal sign. And so what we're going to do next is we're going to say to do items dot to do equals request dot body dot to do. And then the last thing we want to do is we want to say res.send json.stringify to do items at that index. And pretty much the client is going to want some sort of response that it worked. In a real application, you might want to do something else, but for our purposes, we're just going to send the updated version of the to-do item. And so if the user doesn't give us like a good ID, so say they gave us like James for the ID, and we were expecting a number, then we're going to want to send some sort of error to the client. So we're going to say const error equals, and then open and close curly brace. And in JavaScript, this is making an object. And so JavaScript is kind of like Python. It's very easy to just make a object, and it doesn't have to conform to like any like type or anything. So I can put in whatever I want here. And these are just going to be key value pairs. And so basically what I'm talking about is these are the attributes of the attributes or fields of the object. So in the open and close curly braces, we're going to make a new attribute. We're going to call it error. And we're just going to say, we're just going to say item not found. So after the for loop right here, it's going to send. So if it finds an item in the to-do list array that matches the ID that we got, then it's going to send the updated version. Once Express sends an HTTP response for a request, it can't send another. So right here, we're just going to say res.status 400. So what this is saying is in the response, we want to change the status number to 400. So in HTTP, you can send status numbers in HTTP responses, and depending on the status number, it means like something happened. So like 404 means that the resource can be found. 200 means that the response or the request was okay, and it means it went through fine. 400 means that it was a bad request. So we're going to say res.status 400.send json.stringify our error. So if it gets out of this for loop and it hasn't sent a response to the client yet, then it's going to assume that it just couldn't find what the client was looking for, and it's going to send an error. So we're going to save that, and then we're going to make sure that we restart our server. And so after that, we can open up Postman. And so we're going to make a post. We're going to make a post request. So this is going to be the same post request as before. So go ahead and send that. Then after that, we're going to make a new type of HTTP request. So in the dropdown right here, we're going to say patch. We're going to put in localhost 3000 /to-do. We're going to go to our body, and we're going to type in, we're going to make some more JavaScript. So make sure you're in raw, and make sure you go to text in JavaScript, or sorry, JSON. And so right here, we're going to say to do, so before I said make cookies, but maybe I really meant make cookies before 4 p.m. because maybe I have something to do later in the evening. And then the last thing we want to do, this is the most important part, is you want to say /1. So the reason we're saying /1 is because when we made the post request, we made a to-do list item that has an ID of 1. And if you make a GET request, you'll see that in the array we have that to-do item, the ID is 1. And so we want to be able to find that same to-do list item. And so we're going to put in 1 in our patch. And when you send the patch, oops, it's going to say item not found. And so that means we made an error. And give me 1 minute. So what I like to do in JavaScript is I like to console.log things. So we're gonna do that, and we're gonna do some of that, and we're also gonna do some of this. Okay. So we're gonna restart the server. So I saved that. We restarted the server. We're gonna go back to Postman, and we're gonna. First thing we want to do is we want to post the to-do list item. Then we're gonna go back to our patch. We're gonna send the patch, and we're gonna look in the console right here. So, Oh, I know why. Okay. So we forgot one important thing. So in JSON, in our JSON, when we made the that first to-do list item, we put in a number for the ID. So in Express, if you don't, in Express, it's gonna take the ID from the URL and it's gonna assume it's a string. So if I even hover over the ID, it says it's a string. So what we have to do is we have to cast it to a number. In JavaScript, there's no such thing. I'm pretty sure there's no such thing as an integer or a double. Instead, they just have number. So what we have to do is we just have to cast the string to a number. And then it should work. So make sure if you're following along, make sure you restart your server. Also, we can get rid of these console.log messages. Okay, so it should look like that. So we're just going to restart the server. We're going to go back to Postman. We're going to make our post request so that we have one to-do list item. And we're going to go to our patch. And there we go. So this time it worked. So it looped over. It found the item that we had. So there's a match in IDs, and then it updated the to-do list. It updated the to-do attribute with the to-do attribute of the body, and then it sent the updated version. So that's why we had make cookies before 4 p.m. So now we've got 2 down. So we have creating a to-do list item, and we also have updating a to-do list item. So the next thing we want to do, you might have finished the to-do list item. So maybe you made those cookies. So for that one, we're going to say app.delete if we want to delete a to-do list item. And so this is going to be pretty similar to app.patch. But what we're going to do is we're going to say to-do /id. We're going to say request and response. So what we want to do, like I said, it's very similar to the one we just did. So we want to get that ID parameter from the URL. So we're going to say ID equals number request.params.id. Then after that, we're going to do pretty much the same thing. So we're just going to loop over the array with a for loop. And so if there's a match, then what we're going to do is we're going to say this. So we're going to say const deleted to do equals to do items dot splice I. And so in JavaScript, you use splice if you want to remove an item or a certain item at an index from an array. And what this will do is it'll return the item that you removed from the array. So that's what deleted to do is. And then what we're going to do in our REST API is we're going to send the deleted item to the user. So we're going to say json.stringify deleted to do. And we're going to do the same thing for the error checking. So what you can do is you can just copy this from app.patch and then copy or paste it right down here. So as a recap, so it's going to get the ID from the parameter or from the URL. Then it's going to loop over all of the to-do list items that we have in our array. And if there's a match, then we're going to remove that item from the array, and then we're going to send the removed item to the user. If there's no match, then you're going to escape from the for loop, and it's going to send an error message. And so, like I said before, the reason you don't need to check to see if Express already sent a response is because Express will know not to send 2 responses in a row. So there'll be 1 response for every request. All right. So what we're going to do is we're going to restart our server. So make sure you save. And don't worry about any error messages. Well, if you get an error message that says cannot set headers after they are sent to the client, don't worry about it. So what we're going to do is we're going to say node index.js. So it's going to start the server at 3000. We're going to go over to the Postman. So our first thing we're going to do, and so every time we restart the server, basically that array is empty again. So that's why I keep posting. But we're going to post the same thing. So ID1 to do is make cookies. And so we're going to click on the plus over here. In the dropdown, we're going to say delete. And we're going to type in localhost 3000/to-do. And let's put in 5. Let's put in 5. And then we're going to go to body. We actually don't need to go to body. So we're going to send this, and it's going to give us the error, item cannot be found. That's because there wasn't a match. But if we go to 1, then we got another error. to do item is not defined. Do. 45. Oh, oops. All right, so make sure if you're following along in your delete, make sure that you say to do items, not to do item. Make sure it's plural. Okay, so we're gonna save. We're gonna fix that typo. So it was right here. I had to do item. It's supposed to be to do items. So make sure you save. Then you're gonna restart your server. So we're gonna go through the same drill. So if you have the 4 up here, first thing we're gonna do is we're gonna post. Then you can see if you get, you're gonna have what you just posted. And we're gonna go to delete, and we're gonna delete the to-do item with the ID of 1. If we click send, it's gonna send us what we deleted. And now if we try to make a get request for all the to-do list items, it's gonna send us an empty array. So yeah, so that those are create, read, and update and delete. So in other words, those are called the Crud functions. And so those are pretty common for REST APIs. Most of them will have CRUD operations, or if you hear something called CRUD, it just means create, read, update, delete. But that's pretty much what we just made. So yeah, so that's a REST API. For what it's worth, this is all done. I could, if I wanted to, I could keep making new to-do list items. So this one could be send card. If I make a get request, since I just made 2 to-do list items, I have 2 of those. If I wanted to update that first one, if I want to update it to make cookies, or if I want to update that one at ID 1, if I want to update it to make cookies before 4 p.m., I'll send my update. And if I get it again, now it's make cookies before 4 p.m. And if I have made my card, I'm going to delete the to-do list item with the ID of 2. And it's all gone. So yeah, for what it's worth, that's a REST API. But there's more to be desired from this. And so we're going to go into that real quick. So the next thing we're going to do, we are going to make some more files. So in the in your folder where index.js is, I want you to make a new file. You're gonna say touch. I don't know. I don't know if this will work on Windows, but you're gonna say touch to do routes.js. Touch to do routes, and then you're gonna open that one up. Oops, that opened in the wrong window for me. So let me just open that. All right. So basically, what we're gonna do with this file is we're gonna take away some of this logic from the that main file. And so at the top of to-do routes, what we're gonna say is we're gonna say const express equals require express. So that's just like how it was in index.js. Oops. The next thing we're gonna do is that we're gonna make a router object, and to do that, you just say express.router. Oh, make sure you use a capital R. So const router equals express.router with a capital R. And so what we're gonna do now, we're gonna say router.get, and make sure you type /todo. And then after that, we're gonna say request and response. And equal sign greater than open and close curly braces. And so what we're going to do in here, pretty much, we're going to go into index.js. We're going to go to app.get/todo. We're going to cut that out, and we're going to paste it right in here. So I went to app.get, I went to this function, I removed all the contents, I cut them, and then I just pasted them right in here. And then we're going to do that for the rest. So we're going to say router.post/todo. And we're going to get everything from app.post/todo. So right here, so app.post/todo. If this gets confusing at all, feel free to interrupt. But we're going to cut that out, and we're going to put it right here. And make sure you put in your semicolon. And we're going to do the same thing for patch. So now for this one, we have to make sure we say /todo::id, and then request and response, make the anonymous function. So once you have that, you can go into your index.js. You're going to go right here, app.patch/todo::id. You're going to copy all this, cut it, and paste it right in there. And then we've got one more to do. So this is going to be delete/todo::id, request and response, put in that anonymous function, and we're going to go to index.js. You're going to go to app.delete, copy and cut its contents, and then paste it right in there, just like it's from Stack Overflow. And so the kicker here is that at the bottom of the file, you're going to want to say module.exports equals router. So in JavaScript, this is how you say, this is pretty much how you say, like, when you, when another file imports this file, this is what that file has access to. So I'm saying any file that imports to-do routes is going to have access to my router. And my router has all this stuff. So, yeah. All right. So then we're going to go back to our index.js. And we have some cleaning up to do. So we're going to have to clean up all this stuff right here. And so what we want to do is at the top right here, we're going to say const to-do routes equals require. And in a string, you're going to say to-do routes. And you can even say /to-do routes. Then once you have that done, we're going to actually clean up this stuff. So we are going to delete, we're going to delete all this. So you're going to delete everywhere from app.get/todo down to app.delete/todo::id. You're going to delete all of it. We don't need it anymore. Instead, you're going to say app.use slash to-do routes. So basically what we're saying is when the client goes to this URL, so it would be localhost :3000. If they we're going to use, well, we're pretty much just going to use all of the all the handler functions in this file that this router gives us. So it's going to say, okay, localhost 3000, and then it's going to say to do, or C to do, and it's going to know that we have to use a function from over here. And so the last most important thing that we have to do is we have to make sure that we carry over to do items. So everybody just go ahead and copy or cut your to-do list items array. And at the top of to-do routes, go ahead and paste it. And then once you have that done, just make sure that you save everything. And we can restart our server. And then when you go to Postman, if you make any sort of request, it will be okay. So basically we have the same exact functionality, but the logic is kind of away from over here. And so this is kind of this has to do with like separation of concerns. So
Can you just scroll down a little bit? I didn't get that
Yes.
last part.
Right here.
Module.export equals.
But yeah, so as I was saying, it's a little bit cleaner to have this logic kind of separate from this like route handling. And it's kind of just best practice to do. But there's actually even more that we can do to make this even cleaner. So also Matt, is your thing going okay, or?
Yeah, I just have a syntax error. I probably gotta fix that. But
Okay. What's your syntax error?
I think I just forgot like a semicolon, or I think I forgot like a brace or something. I'll figure it out.
Yeah, if you need any help, feel free to let me know. So what we're gonna do next, we're gonna say touch to do controller.js. This is gonna be our last one. And so we're gonna open that up in our text editor. And so basically for this one, this is going to be like a controller. It's going to define all the functions that we want to use. So in our to-do routes, we still kind of have like the logic kind of mixed in with how things want to be routed. So basically, we're going to remove all this logic and put it into this file. So the first thing that we want to do is we want to define all these functions. So this is how I'm going to say. So, all right, so for this one, we're making a function. So JavaScript is kind of wonky. So you can make a variable and make it equal to an anonymous function. But so the function is called to do, or I guess the variable is called to do index, and its value is this function. But basically what we want to do here is what we did before. So all we want to do is we want to go to router.get/todo, and we want to cut that out and put it right here. And so basically, to do index is just going to give us all the to-do list items. For the next one, we're going to say to do underscore create, and this is going to be the function that's responsible for creating a new to-do list item. And so we're going to do another copy and paste. So we're going to take everything from router.post, or I should say the body of that function, of the anonymous function here. We're going to cut that out, and we're going to go into to-do controller and paste it. And we're going to make another function. We're going to call this one to-do underscore update. And so once we have to-do update, we're going to go back into our routes. We're going to look at router.patch/to-do/:id. We're going to take all that out, and we're going to put it right in here. And lastly, we're going to say to-do_delete. And we're going to take everything from the delete right here. So just copy or cut that and paste it right here. And then this last part is very important. So like how we said module.exports equals router and to do routes. And here we're going to say module.exports equals open and close curly brace. And so this is basically kind of saying like it's an object. And we're going to put in all these variables that we just made, or functions if that makes more sense. And lastly, to do delete. So in our module.exports, we're making a new JavaScript object, and we're putting in. And also, this might not really be a JavaScript object. I don't know if if James or Robin, if you know better, but I've always thought of it as like a JavaScript object. But so we're gonna put in all the functions that we just made. And so that's going to let us access those functions from outside of the file. And the most important thing to do is we want to go to to-do-routes.js, and we want to make sure we take the to-do items array. So we're going to copy that, or sorry, cut it out. We're going to go to the top of the to-do controller and paste that in. And our to-do controller is all set. And then the last thing to do in to-do routes is to just clean it up a little bit. So what we're going to do is we're going to get rid of the second, we're going to get rid of this anonymous function. So you can just go ahead and delete those. Okay. And the next thing we're going to do is we're going to import that controller. So we're going to say const to-do controller equals require / to-do controller. And now what we're going to say is whenever the router gets a GET request, we're going to say to-do controller dot to-do index. So if it gets a GET request with this type of URL, it's just going to give it all the to-do list items. And so when it gets a post, we're going to say to-do controller dot to-do_create. And in router.patch, we're going to say to-do controller dot to-do update. And in router.delete, we're going to say to-do controller dot to-do delete. All right. So we've officially removed all of the logic from the routing. And so things look a lot cleaner, at least to me. I hope that you also agree, but our index.js is pretty small. To-do routes.js is pretty small. To-do controller is kind of big. It's bigger, but it contains all the logic. But that's a big problem that a lot of controllers have if you use that type of pattern. They get really big. So there are other design patterns that you can use. But yeah, so if we restart the server, and if we go back to Postman, everything should work just like how it did before. And make another one. I'm going to patch that. we're gonna get this. There you go. All right. And so yeah, that's pretty good. I have one final nitpick though. And so there is a little bit of redundancy right here. So instead of saying /to-do for all of these, we're actually gonna delete that and make sure that in the patch and delete, it's looking like just /:id. And make sure you save to-do routes. And then we're going to go into index.js. And we're going to say right here where it says app.use /to-do routes, we're going to say to-do. And now whenever you make a request to a URL that has /to-do, it's pretty much going to go here, and it's going to say if it's just to do, then it's going to do a get. If it's a get request and it's just to do, then it's going to do this. But you can kind of think of it like this. So basically, it's just kind of like predefining that first part of the URL. So since we have to do right here, whenever I make a URL, basically this is saying that for each, like for this pattern after to do, so if I just put in, if I just put in a 1, then it's going to know to go here. But it's just another way to get rid of redundant code. But yeah, so that is that's all I have. And so yeah, that's a pretty basic REST API with CRUD operations, and it's split into routes and controller. So yeah, I would recommend using this type of well, I would recommend splitting things up. It makes your code a little bit neater. But yeah, and so that's all I have. So looking at the workshop text, it looks like David has a question. I know it's not typical, but what would happen if your array happens to contain 2 same ID? Would it send 2 responses? So if it contained in our scenario, if they had the same ID, I'll show you that in 1 second. All right. So if I had an array, if I make if I have 2 to-do items with the same ID right here, it's just going to fix the first one. So what I mean is when I do a patch, if I go to the first one right here, because of how I defined it, it's just going to update the first match that has that ID. So if I go to my controller, when I update it right here, so it's gonna look for a match in this for loop, and if it matches, then it's going to update it and then send a response. So I believe what this is going to do is it's going to update it's actually going to update all of them, but it's only going to send 1 response. And so let's see if I'm correct. Yep, so it updated all of them. Yeah, I hope that answers your question. There is no debugger. So there actually is a debugger in VS Code, but I have very bad habits and I don't use the debugger. So yeah, if you want to use the debugger, I don't know if I'm ready to demo that, but yeah, there is a debugger. Robin says it's not a bad habit, but Robin also has the same habit, so Robin is very biased. Oh, Robin's time. Robin says no, I am not. Yeah, so that's all I have. No, Robin is typing. We still debug. Yeah, we do still debug. Yes. But yeah, does anybody have any other questions or?
No questions? None? Wow. That was a great workshop, Tony. I think you did a good job.
Yeah, so well, if nobody has any questions, then I guess we're good to go. But before you leave, I think, well, James might have some announcements, but also the code for this workshop will be available on GitHub. So if you couldn't follow along, if you came across any issues, I will have some stuff up on GitHub so that hopefully you can try to figure things out. But yeah. Yeah, I guess I'll hand it off to you, James.
Excellent. Thank you, Tony. Big round of applause. That was a great workshop. I think it was just the right length. You covered all of the core ideas of REST APIs. I think it was overall really good.
Thank you.
So about the schedule. So tomorrow we're having side project development night. I'm going to be showing off a cool project that I stayed up way too late last night working on. I've made a GPU accelerated Mandelbrot set that does zooms. Normally when you look at Mandelbrot sets, you have to wait for them to load because it does each pixel independently to calculate whether or not it's in the Mandelbrot set or not. But by doing GPU acceleration, using fragment shaders, you can calculate all the pixels on the screen in parallel, and it renders extremely fast, and it's very cool. So I'm going to be showing that off tomorrow night. I'm sure there's also a bunch of you who have projects to show off tomorrow night as well. I'll be talking a bit about how GPU acceleration works, and just for those of you who don't know what OpenGL is, good luck, because OpenGL is not fun. If you have yet to experience OpenGL, it's quite the ride to get on. But beyond that, next week we're having a slew of interesting events. I believe we're having. Okay, so Monday is going to be professional development night. Nothing on. Oh, Monday is also going to be. Next week is SA Tech Week. We're going to be doing an introduction to Python workshop for absolute beginners on Monday at 7. And then that's going to be followed by our coding night at 8. And we're actually going to kind of combine the events. We're having the introduction to Python at 7. And then for everyone who doesn't really care about the introduction to Python but just wants to try some problems, that's at 8 like normal. And then Tuesday, nothing. Thursday, or Wednesday and Thursday, I think we have 2 workshops next week. Am I right about that? Does anyone have the schedule up? I think that's next week. Unless I'm absolutely insane, which is also possible.
Yeah, we do.
Yeah, next week is the 2 workshops. Excellent. Okay. And then after that, we're going to have side project development night again on Friday. And before we wrap up, I just wanted to make sure everyone's aware of the voting schedule, because we are having e-board elections this month. If I can just find where I posted my announcement for that, that would be excellent. Here it is. Okay. So essentially, it's, the e-board elections, there's going to be 4 positions up for election next semester. It's the chair, the vice chair, the treasurer, and the secretary. So basically, here's how this is going to work. You have to have over 50% attendance to run, and you have to have over 30% attendance to vote. Officially, we only count people a member if they have over 30% attendance, and membership is the threshold to vote. Therefore, essentially, you can. So we keep vigorous track of attendance. Talk to Tony to get your attendance. Tony ran the calculations last night for the preliminary attendance. Attendance for voting will be locked on the 16th. So you have all of next week to try and get up over whatever thresholds you think you might need to pass. There were a few people I know who the bot didn't pick up. So if you think you have really good attendance and we don't see you on there, we can attempt to guess and check and figure out which one of the high attendance numbers you were. On top of that, so the 18th is going to be the deadline to declare your candidacy if you're planning on running. The 19th through the 22nd is going to be campaigning. And then voting is going to take place on Friday and Saturday, the 23rd and 24th. And then finally, we're going to announce our results on April 27th. And then we will transfer power over the following semester. Just remember that the e-board positions are probably highly competitive. I have yet to see any, well, there hasn't been much campaigning yet, so I'm not entirely sure what we're looking at in terms of running. But if you want a less intensive leadership role, but still are interested in leadership roles, JBoard and DBoard are going to be up for interview in October. So if you're interested in a junior position or a director position, that's in October. So, and those are application. They're not elected. You apply and the e-board decides who gets what positions. So keep that in mind going forward. And with that, I think that's everything that I was going to go over. Any comments or questions about the election process? Okay. Well, with that, thank you for coming, everyone. Thank you again to Tony for hosting the workshop. It was great. All right. Bye-bye. Have a nice night.
Have a good night, guys.